what you have done such that you are able to lean towards the expected results. That is another challenge. And then the third is time and patience. That's like I think my biggest with time and patience. Because with science, we all know that it's an issue of experimentation and observation. And we know that for you to experiment, it takes time. You may not get the results the way you want at the expected time. And then there are certain processes that you just need to be patient with. If you rush them, it's not going to work. Yeah, so I'll say like these three are the three off the top of my head that I can say are the challenging bits about research. Now, the fun part about the research is when your results actually match what you want. So, if you have a research topic, usually your research topic is tailored towards um, answering a particular question. In it could be a social thing that you're trying to solve, like mine. So, if your preliminary results tend to lean towards a solution, it's usually very exciting because now you know that okay, what I have done as first research is giving me some results, and then it looks like it's going to be scalable. So once it's scalable, then it means you'll be able to answer certain questions that pertain to your research topic, and that gives you some bit of joy. And then some of the processes in executing your experiment are also fun. But then the biggest is when your results actually match your expectations. I'll say that's like the fun part of doing research. Yeah.
Definitely taking notes.
Yeah.
So, as a scientist, how is your approach to solving problems similar to how tech innovators think?
Okay. So I think I'm not so much of a big tech person, but then what I know is for tech to come out, they look at the broader market and look at what a pertaining problem is, and then how they are able to solve that issue, who their should I say audience or primary market is, and the value of what um, they are offering as a technical solution to the problem. And it's pretty similar with research because technology, innovation, and research all fall under science. As such, they follow the same principles. So, just the same way a technologist or somebody in the IT field would want things to happen, it's the same with us as well. So we also look at the broader um, space, what the challenge is. So I'm going to use my research as an example. So I'm looking at the broader space, like Ghana. And I'm like, what's a pertaining issue at the moment? And we know it. And I'm saying, what is it doing? It's destroying our water bodies. With what exactly? There's mud and then there's heavy metals. So I'm like, okay, what innovative way can I work on this? And then as I'm thinking of that innovative way, I'm looking at costs in terms of how I go about my experimentation and getting my results. And then if my preliminary results tend to lean towards a good expectation, then I look at is this scalable? And if it is scalable, how would I be able to channel this towards the public? And then afterwards, how would I communicate my science in a much simple term such that a layman on the street anywhere would be able to understand and appreciate what I am posing as a solution, and then economically if it has value to them as well. So it's this I would say it's practically the same. Just that I'll say technologists are usually looking at um, value for money, like profit and stuff. But as a researcher, some of the solutions that we come up with, we may do will be to patent the ideas and stuff, but then those ideas will be given to actual tech companies, and these tech companies are now going to base off the ideas and the results that we've given them primarily into solutions. So I'll say those are the slight differences between technologists and research.
Okay. So, how important are curiosity and collaboration in research? Do you think as someone can single-handedly just do a whole research and bring solutions to certain problems alone.
Well, if you want to do research on your own, then you should ensure that you are well resourced because research, trust me, is not cheap. So for curiosity, I mean, if you are not curious, you will not be able to ask whys. You just follow protocols, follow the status quo, and come up with results like anybody else. But if you're able to question why everything happens, then that forms the basis of research and innovation. Because as I'm asking why, somebody will explain it to me in a different perspective, same as another person, same as a third party. And then by the time I realize I have so many perspectives to one particular solution, and then from there, innovation is birthed. So now you can think of one particular channel to tackle your problem from, and then that is how research comes about. But then for one, I don't think it's possible for one person to do research on their own. Why? Because research involves a lot of collaboration. The reagents you need to buy, you cannot manufacture them on your own. You probably have to buy them from the chemical shop. Some of the antibiotics you need to buy, you need to get them from pharmaceutical companies. Some of the research that you conduct, you need to work on humans. You need to take samples. So therefore, you need people that are able to grant ethical clearances for you to do what you need. Some of your results, you may not have the devices that you want to measure. As such, you have to go outside, you have to outsource. So it's extremely difficult to say that one entity or one individual will be able to do a full research on their own and come up with substantive results without having to collaborate with at least one or two people. Even those who are going to provide you funding to undergo your research are um, also collaborators in the ways to say. So I'll say it's very challenging to say that only one person will be able to undergo a research and bring out something substantial without having to collaborate with anybody else. So curiosity plays a role because that is the drive that pushes you into research because you always want to find solutions to things, and those things come up as a result of you asking a lot of questions, hence curiosity. But then for research, I think it's collaborative and you need a lot of hands in order to ensure that it happens and happens successfully.
Thank you for the input. So, right now we are going to your project. I was hearing some really interesting stuff.
Yeah.
Can you tell us, like, how you came up with the idea to embark on this project? Like, why did you choose this project?
Okay. So why did I choose the project? As I said, thinking like a scientist. So I start my national service and we are at liberty to pick up projects provided that the lab that I work in has the resources to support what I am doing. And so we come up with a lot of things. We look at problems. So my lab has main research goals, like they will focus on Buruli ulcer, but then what I am doing is more of bioremediation, right? So we look at a bunch of problems plaguing the country, and then we know typically one of them now is galamsey. And so as a scientist, we are thinking, what's an innovative way that we can do this? And so in collaboration, as I've earlier mentioned, with one of the partners for the lab, we come up with ways by which we can use insects. Because of copyright issues and patency, I will not be able to share the extreme details of my project. But then what I'll let you know is that I am using insects called black soldier flies. And then in the end of my project, I'm hoping that these black soldier flies that I'm using would be able to take out the heavy metals from our water and ensure that the water is safe for use. So this is a very innovative way of thinking because one, I find myself in an institution that thinks a lot about infectious pathogens, right? It's practically in the name. So they are thinking about malaria, we are thinking about leishmania, we're looking at a lot of things, right? Really also and cool. But then in my lab where it's a molecular slash microbiology lab, here is me coming up with a project far away from infectious pathogens, but then I'm looking at something that is environmentally concerning, which is galamsey. And since the lab still has the resources to support my research, they are able to do so. So that's like a little bit of my research, relying on insects and entomology to solve issue of galamsey, which is a social problem in Ghana.
I personally know that your research has a bit to do with biotechnology,
Yeah,
right?
yeah.
So, how do you plan to use your data from the lab to generate like the actual solution? Like, what are you going to use the data or the analysis you've been able to achieve in the lab to make it scalable for people to use? Or I don't know if you understand the
Yes, I
question.
understand. Yes. And so, God being so good, I have completed like the first phase of my project, and I
Ooh,
have like preliminary data to show for it. Um, and the data is looking somewhat good. And so I'm planning to run like a second phase, ensure that all the gaps that I missed out in the first one, I am covering them up in my second. Now, how do I intend to link these two from my research with biotech? Now, the solution that I have is on the brink of molecular biology and material science engineering. And so my solution is like the core of the item, right? And so
okay.
now I'm going to give that core, which is an idea, I'm going to have to link up with material science engineering students or personnel who will be able to develop a functioning tool out of what I have, right? So let's say my research is a drink sort of. Now the material science engineers are going to look at, okay, how can we store the drink? How can we transport the drink? And what would the shelf life of the drink look like? To which people is the drink going to and all that? So when they put together all these considerations, then they will come up with a functioning tool with my idea as the core of the tool, and then that will be deployed. And that is a bridge between biology and tech. So I am working in the biology field, finding the solution with my research in the field of biology, and then from there I pitch my ideas to the technologists, in this case your engineers or material science engineers, who then come up with a solid model of my solution with what I have at the core, and then that will be deployed into the communities, health facilities, schools, households, etc. So that communities that tend to live within these quarantine areas will find a way or have a solution to their water bill. Yeah, so that's how I link the two.
I'm curious. Do you think when your solution becomes scalable, it will make like people ask the government to allow them to continue galamsey since there is a way for them to purify the water at the end of the day?
Okay. And so just because my research has been able to provide a solution doesn't mean that it gives them the right to be able to continue what they do. Do you understand? Because what they are
Mm.
doing is illegal. Because with legal small scale mining or surface mining, they end up covering their tracks and ensuring that they do not cause as much even if my solution turns out palpable and it's able to help the society by purifying their water and all that. I don't think, even though yes, people may have that idea as we already have now, that okay, since there's a solution, then let's just continue with the galaxy because if we end up destroying our water bodies, we have a solution in the end. I don't think whatever I am building or my upbringing morally, socially, and even in terms of science will permit that. So yes, people are at liberty to think whatever they want to think, but then I don't think it's a good idea. I don't think so.
Because it just came to mind. I'm like, oh, people will actually be saying, ah, so there's a way to purify galamsey water. I mean, if we just have this machine, pour the water inside, they'll get purified water to drink. So why don't I continue illegal mining and get my money? and still give them good water to drink.
Yeah, I agree, but then we can't risk our environment. I mean, it's from the environment that we all exist and we all survive. So just because we have a solution doesn't give us that legal or moral right to keep destroying it. It's not the best.
Okay, fair enough.
Yeah.
But I really like your project because it will give time, it will allow the government enough time to actually get rid of this illegal mining thing without causing too much damage to the people.
Yeah, I agree. I agree. I agree.
Okay. I have another question. So, do you think there should be more collaboration between scientists and tech developers to boost innovation in Africa? I'm asking this question because I know most, especially biochemists, like researchers, mostly publish their findings. So, do you think it, um, you get tech developers and people who can actually make it scalable so that when it is published, then it just moves to the next phase of making the solutions available to the people?
Okay. So here's the thing that most people don't consider. With collaboration comes politics, and with politics comes money. As such, there is always like a divide when it comes to collaborations. Because if I want to collaborate with you, it means there's something in it for me. Now, if I'm collaborating with you, who owns majority of whatever idea we are pitching as a solution? If whoever owns majority, now how do we split the income? How do we split profits and whatnot? All those things come into play. And so as biochemists, I mean, in publishing, we are at liberty to publish because that is our finding, that is our ideas, and then we are at liberty to publish those things because we did the research and we have the rights to do so. However, when it comes to collaboration with these tech companies and tech gurus, I would say that there should be structures in place to ensure that these collaborations do not end up um, biting them in the tail, in the sense that there shouldn't be much politics involved and then ends up destroying whatever solution that they come up with, right? So there should be measures in place, there should be standards, there should be agreements in place to ensure that once a scientist is willing to collaborate with somebody in tech, there are standards that show ownership, the profit margins, and all those things, so that way it bridges peace. But for me, I'll say yes, collaborations between the scientists and the technologists is really important because as researchers, the most we can do is to put out findings. But then if these findings are not taken up by people who are able to convert our scientists, our findings into real and practical solutions, the findings just remain findings. And so I am really somebody that enjoys translational science because if you tell me you have found something, how is it that we can work on what you have found and make it into a solution, a visible one, something that is tangible, that the whole world can see and can also solve problems? So yes, with research, we cannot be faulted too much for not making products because that is not what we are supposed to do as researchers. Ours is just supposed to find and publish, and then from there, with the knowledge that we have and our IPs and whatnot, these tech companies are supposed to come into collaboration and ensure that these ideas that we have found from our lab work is translated into tangible solutions, and then these solutions are put out there for the benefit of the community. So yes, I agree with collaborations, but then these collaborations have to come in structured manners so that in the end everybody is safe, everybody is happy, and then in the end the solution still works regardless.
Yeah, because I mean, it will reduce the, should I say, struggle or burden on the technologists because they will also have to now, find a problem, do so much research on it before they find a solution that is scalable. So if there's a collaboration, you guys do all the research and that part, then they just zoom straight into getting the solutions for us.
Yeah. So you see, usually when these ideas are published, it comes with copyrights and all that. And for you to collaborate, as I said earlier, politics and money. So all these things make it look like everybody wants to stay in their zone, sort of. Because if you want to come into my space, it's my idea. How much are you willing to contribute towards it, and all those things. But then, if we are able to push structures in place and get those things aside, we'll have a lot of really cool and nice solutions to make the world a better place to live
Yeah, because from my time at WACCBIP, I've seen that there's a lot of good and scalable research going on over there. That if
in. Yeah.
there were a lot of collaborations with developers, we would have really cool things to use and yeah, how could
Okay.
yeah.
So, with the aspect of AI, I am a big enthusiast of AI because I believe that as humans, we are supposed to be as efficient as possible. And by efficient as possible, it means you need to get work done quickly and you need to do it fast and in the shortest possible time. And thank God these large language models which we have as AI activities and whatnot are developing in capacity to be able to do that. So in the past where for me to publish a paper or for me to write a whole literature review, I had to read tens of thousands of articles in order to pick out ideas and then put together my literature review with my AIs. The time that I have is limited because now it is easier for me to find the papers as early as possible. It is easier for me to read through them and get my key ideas for my research. And so for me, I'm a very big enthusiast of AI. People are like, oh, AI cause a lot of trouble. You need to automate it. You need to make it faster. It makes mistakes. Yes, I agree with that. That is why you should not use one particular AI in isolation. Or even if you are going to use that AI in isolation, you should be well vested in it before you go ahead with it because the issue of research and innovation comes with a lot of science and accuracy. So you cannot be haphazard about your research using just AI and then you believe that what you have come up with is good enough. So you should be somebody who is knowledgeable in using these things and you know how to verify your information and whatnot. Because I believe most of us in the university, for example, we have tried to use AI for say assignments and stuff and realize that the information it gives us and then the actual information below sometimes is false. And so even when you query the AI, it goes giving you apologies and whatnot. So I believe AI has come a long way to help us because now it makes our workload easy. Getting of papers for my research is easy. Writing now has become a little easier because it enables me put all my ideas together. Whatever I've done in the lab, I'm able to structure my writing properly and all that. And these large language models are usually connected to the internet. I have worked with one particular language model for biology, and these AIs are really getting smart up to the point where papers are being written as early as 2 months before I started the training. The AI was able to capture those papers and pull out key information from those papers. And so I'll say AIs have helped us a lot with our research because these models are now connected to large databases that have articles and loads of articles that we need to source for our literature reviews, and then from there we are able to pull out key ideas that we need for research. So I'll say AI helps, but then as a scientist, we shouldn't be overly dependent on these AIs. We should also try to get innovation from within because these models are trained on the basis of knowledge that they are privy to. But then as humans, we are able to think and we are able to think way better than a computer would ever do. And so it gives us ways or innovative solutions to everything, different perspectives, ways we are able to humanize emotions, etc. And so yeah, AI is good, but then I'll not say it's 100%. We still need to get in touch with the human aspect of research as well because the AI is not going to be in the lab to do the lab work for you. The AI is not going to be there to mix the chemicals and if it is build tech, do all the hardware and stuff for you. You may get the software bits, yeah, but then the rest of it will be you and how you handle things in the lab. And so if you do not have that expertise of how to work in a wet lab, and then all you depend on is AI, then you have a problem. have a bit of struggle. And so yeah, I think that's AI in research and innovation.
Okay, that's true. What advice will you give to students, especially those in the non-tech fields, on how they can also contribute to, sustainable innovation and
Okay,
yeah.
all right. So just because you find yourself in one field, does not mean that you cannot work with another person or you cannot have. For example, we have medical doctors now who are not leaving the medical field per se, but then are developing more interest in research because according to them, medicine is getting a little bit thin and they want to find new ways to stuff. And so if you find yourself in a non-tech space, what can you do? You can still look out for problems or challenges that you think you may want to solve. And as the youth that we have today, we have to think and be like very innovative. And so you have to think of ways, clever ways which are cost effective, sustainable, that you can use to find solutions to these problems. And then what do you do? That is why your social community is really important. How you network with people and stuff is very important. Because, for example, for my research, here's me who was based purely in biochemistry, cell and molecular biology. But then now I am working on things that have to do with material science engineering. So if either me or my immediate supervisors did not have these connections to people in these areas, I think my research idea would have just stalled, right?
That's true.
But then because I have these friends, so as you are going to school, ensure that you have friends not just in your department, but then everywhere, right? Friends who are impactful and will contribute some meaning to your life, such that when you find yourself in a non-tech space and now whatever you do can still be related to tech. I believe almost everything we do in this world we need some bit of technology. Even now, the churches which are purely spiritual depend a lot on technology because there's projections going on. The pastor needs to see scriptures in real time as he mentions them, sound systems, all that is technology. So I don't think there's any field that can survive now in the world without any bit of tech involved. And so if you find yourself in an aspect of non-technology, there's always a way by which you can come back into the tech space. Just like how people who find themselves in the non-science space would always trickle their way back into science, find a way to get back into science. So if you're in a non-tech space, don't find yourself to be missing or lost. Focus on your area and make sure you are well vested in it, such that when you start to get innovative, as you are reading and you are broadening your scope and you have a good social network, you'll be able to find key areas by which your non-technological space links with. And via your connections, you'll be able to link up with those people, pitch your ideas to them, collaborate with them, and from there, your ideas will become tangible.
Thank you so much. Please now,
Yeah.
if anyone has any questions for Yom, you can ask him. Please, any questions for Yom? Okay, I see it. Okay, Alexa.
Okay, so what tools do you use for your research? So websites or specific AI tools that are less prone to giving false information?
Okay. So when I'm doing my research, some of the websites that I use are Mendeley. I use Google Scholar a lot, and then mainstream Google a little bit. I use that as well. Then when we come to my AIs, I would usually like conventionally chat GPT. There's DeepSeek, there's Perplexity, there's a host of AIs that I use. And then this is what I do. I ensure that whatever I am researching on, I go onto these websites that have journal articles on there and try to read. And then if I'm not getting what I need, then I move to these AIs and try to see if they are connected to these databases that are able to pull out the articles for me. So say I am working on something like parasitology at the moment. I could input that particular topic that I'm looking at in parasitology. I could put that on an AI like Perplexity, and then it's going to give me papers. You could also use another one. It's called connected papers. So if you put your topics on there, it will link you to a lot of papers connected to your topic, and then from there you are able to read and then get your innovative ideas from there. But then for my top research, what I do, ChatGPT, DeepSeek, Perplexity, Anara, and a few others. If I remember, I'll share them with the host so that she can share them with you as well. But then stream, I do a lot of Google search from Google Scholar because obviously there are a lot of articles from there. Other websites I can use PubMed, Nature, Elsevier, a lot. Yeah. So those are like a few ones that I use for my research.
Okay. Please, any other questions? Oh, Alexa.
Oh, I said thank you very much. That's what I
Oh,
said.
okay.
Yeah.
Please, any more questions for you? Mike, Michelle, please go ahead.
Please, I wanted to ask what are some common mistakes that researchers make?
Okay. So some common mistakes that we will make, for example, let's say I want to perform something in my lab, and then I go online and then I read, and then I don't read enough articles, right? I just pick like one particular article, then I'm trying to follow what they do in the lab. That I would say is one mistake that would be quite, because one article may not be enough to verify what you do, right? Because with every experiment comes some particular conditions that you may need to run them through. And then particular article, and then that experiment was done in Germany. The conditions in Germany may be different from the conditions in your Ghana. Compare the protocol, whatever you're doing. You need to ensure that the conditions are usually the same, or you find a way to tweak the conditions to suit what you have in your country so that you can easily work with it. So I think some as early career scientists, reading a lot of papers is usually very tiring because I mean, they are scientific papers. So I think that is one mistake that we make as researchers, not reading widely or as enough papers as possible before jumping on a conclusion as to what we want to do. Another mistake that a researcher can make is forgetting to make replicates of your experiment. So, for example, somebody starts out an experiment and then they run out just one scheme and they don't try to run replicates. So, what by replicates I mean, let's say if it is an experimental setup, I have like three of them, and either I'm running them consecutively or one after the other. What that it gives me enough data. So at least from one experimental run, I'm getting like three sets of data, and then that gives me like enough statistical power to prove a point from what I am getting from my research. So I think another mistake that we make as researchers is not um, getting enough replicates. Now, another thing that I would say, which is not necessarily a mistake but a challenge to research, would be funding, because sometimes you, as a researcher, you know that I need to run replicates, but then it will be very challenging. Why? Because you don't have enough funding as possible to run your replicates so many times, and that gives you a lot of problems. So off the top of my head, these are like a few mistakes that we make as researchers. But then I mean that is what makes research fun, because even when you make the mistakes and then they are pointed out to you, it becomes a new eye opening. And that also is another field of research that you would want to look into and find out ways to perfect your work. Yeah.
Thank you for sharing that with us. Ajoakia, please go ahead.
Okay. So Yom, my first question is you mentioned something related to funding just now.
Yeah.
And so I wanted to know, so the current research projects you're working on, I'm guessing you are probably funding yourself, but there's situations where like you could get funding from outside, and if there is, how do you probably like put out a petition or something that's funded?
Okay, okay. So at the moment, I am partially funded in a way because I'm not doing anything in relation to infectious pathogens, and so the funding is partial. I'm still trying to pitch ideas and get that. So I like the idea of you asking because if you have an idea and you want to run research towards it, you need money, you need funds for it. And so the first thing you can do is look out for what we call grants, right? You have to look out for grants. And with these grants, you are going to get like institutions, companies that are worth your time. So let's say if I'm doing something in relation to the environment, I want to pitch my ideas to institutions that care about the environment and institutions that I know that fund research in relation to caring from the environment and all that. And so when you find these institutions, you try to write your experiment or your research in such a way that it is understandable to these companies. And then they know that if they should invest in whatever you are doing, you are going to get them tangible solutions. And then in the end, they're also going to meet their targets. If so, some of these companies, their targets is either to make profit. So if it's for them to make profit, then it means whatever solution you are bringing in is going to rope in the profits that they need. If it's not about profit and it's just about touching the lives of people, how many lives can you touch? So mine like this, how many lives around these Galamsey communities would I be able to work on, right? So for you to pitch out your ideas, you just need to ensure that you are narrating your idea about your experiment or your research in such a way that it is appealing to these funders. And then those funders will be willing to give you a grant in the form of money or resources to be able to undertake the project. So, for example, when you come to the University of Ghana campus, there are a lot of programs for startup companies, businesses, research ideas, and all that. And once you are able to pitch your idea, you are able to pitch the idea that you have to these people, and then it makes meaning to them, and they find it feasible enough, then they may choose to award you these grants and then resources to ensure that the idea or the research that you plan to do, you put it in place and then ensure that it comes into fruition. So that is how you get your grants or funding for your research.
Okay. My I have another question.
Okay.
So the next question is, how do you think your research is going to inspire other sustainable solutions using AI?
Okay. And so I believe that with my research, once I'm able to come up with even better results that have social impact, and then I'm able to narrate my story of how I came about everything, definitely it's going to get to a lot of people because looking at where I started from and what I am using in terms of my solution, most people would then begin to think of problems in different perspectives and try to find solutions to them. And hopefully, if this works and I'm able to pitch it to like even larger communities, larger farm groups, and all that, you realize that there is hope for technology and innovation and biotech on the African continent, especially in Ghana. And so that will give them or give other biotech startups a chance to also get access to these funders in order to ensure that, okay, they get the money that they need to run their research and ensure that they are also putting up solutions in other fields that also are related to biotech research and innovation, and then in the end contribute to the success of the country as a whole. So I believe that if mine works out and then I'm able to get the social audience that I need, then it's going to help us, um, and going to help other startups, other research um, institutions as well, pitch their biotech ideas and ensure that they get the funding that they need and put out these solutions to help the country. And please, is your question answered?
Yes, please. Thank you very much.
Yes,
Okay. Please, any more questions? Okay. I think there are no more questions. Thank you so much, Yom.
Yeah,
It's been
thank
a
you.
very enlightening evening. I'm reconsidering. I always thought research was boring, like sitting down and reading so much. But well, I have a new perspective.
Yeah,
So thank you so much for sharing your journey, your experiences, and your project with us. And
yeah. I'm also grateful for the opportunity to speak to everyone here. I mean, it was a lovely meeting. I like the questions, and then I also like the Q&A session, the kind of questions that we asked. And my advice for us is let's stay curious and let's stay innovative because there are so many much solutions that we have to the world's problems. Just takes us defying the norms and thinking outside the box, not thinking like everybody else, asking the right questions, and then from there, we're able to come up with ideas and hopefully get the resources that we need to bring these things into life. So let's stay curious, let's not give up, let's stay hopeful. And in the end, we'll be able to achieve great things as researchers, scientists, innovators, and people of tech.
we will definitely keep that in mind.
Yeah,
I think Pokia has some announcements for us. So, Pokia, please go ahead.
All right. So, as most of you know, if you are in the WhatsApp group or you've been following us actively on social media, then I believe you've heard about InnovoTech Launchpad, which is a boot camp coming up. Yes. So InnovoTech Lab has a boot camp coming up in partnership with, yeah, Elevate Network. Yes. And the boot camp is going to be a very exciting one. So you're going to learn about robotics and IoT, software engineering, AI, and also career growth and entrepreneurship. I know most of you here are thinking about what you want to do in future, and some of you are even planning on starting something of your own, a startup or something. So come and learn about entrepreneurship. Come and learn about how to go in your career as well. And the price is very moderate. I believe it's quite affordable. So you guys should register to join. Caroline, can you please put the link in the chat? So you got those of you interested should register to join. It's 1,000 CDs, and you can be the board inside is going to be a Raspberry Pi Pico 2W. Yes. So you guys should register to join the boot camp. People are registering, and so the slots are filling out very fast. So if you are interested in it, then I would advise that you register as soon as possible because we'll be closing registration soon. So I'll see you all next week Saturday. We would have another session next weekend. An announcement will be made during the week on what the session is going to be about. So you guys should register as soon as possible. And before we leave, we want to take like a picture, like a screenshot. So if you are in a suitable condition, please turn on your camera. Was Yom and also Caroline.
I don't know if I can turn my camera on. Just a second. Coming. Okay, we are
You
done.
people want me to turn on my camera. I look terrible.
I was literally in a bonnet book here. Thank you so much, Yom. It was really refreshing and enlightening hearing about research work and how to scale it up.
You're
So,
most welcome. And definitely, I'll be willing to join the call again as and when I need it. So,
woo! So thank you everyone for joining. See you all next week for another session. Bye for now.